Let's continue our review for the final. So let's look at some of the theory associated with object-oriented programming. What's the difference between unstructured and structured programming? We discussed that unstructured only has main, basically. Everything goes in main. And in structured programming, we start dividing the function in the program in several functions and the structure that some are, and the data is passed to functions. Some are managed by main, some are managed by the functions. We talk about different types of structured data, having libraries or modules, and the traditional just functions. So what's the difference between now structured programming and object-oriented programming? Structured and the functionality primary, and the data is passing through the functions back and forth. On object-oriented program, on the other hand, we focus on the data and we create methods to access that data. So the data is not passed in a sense that the functions have the objects have full control of the data, and they're not passing back and forth like the functions will do it. What we call information hiding. The idea there is to keep the data private and using the methods to implement whatever you needed to do with a function, but we have a concept of an interface that allows that to be unique and not change, while what is inside can change inside of the object. So, so we can change, and whatever we change inside of the object is not going to affect whoever is using it. So we keep the information private there. What's the difference between a mutator and accessory method? Mutators would be methods that modify attributes, and accessory we won't modify. So accessory is marked by a word constant at the end of their name. So what's a constructor? Constructor is a special method that is called upon when the instance of object is created, as declared. Instantiate the object, allow us to initialize whatever parameters we need within the object in the creation of the object of certain class. What is a destructor? It's another special method that allows an instance of the class to be terminated. At that point, for example, we can close files, we can deallocate memory, anything we need to do to ensure that a object will terminate correctly. What does it mean to say that a class is composed by another class? So we talk about composition. The whole idea is that one class will use attributes as objects from other class. For instance, we talk about a car, and then we could have a car being composed by an engine, which is an object from a different class, or by a transmission, and so on. So we had also the example that, like for the animal class, we had a date, which we use to represent the birthday. What is inheritance? Inheritance is when we create new class, what we call derived class, from another class, which is a base class. So you're going from a more generic class to a more specialized class by the inheritance process. What is polymorphism? Is the ability to associate many meanings to a function name or to a method name by many units using virtual function relate binding. That's the dynamic form of polymorphism. There was a couple other forms we look at, like for example the overloading, where it was called ad hoc, or the parametric polymorphism. But a more important form there is the virtual functions or method. What is a virtual function or virtual method? It will be a function or a method that will be replaced when a specific derived object is created. So on the beginning, we have on the parent a generic method that will be later replaced by the more specific method on the child that's created on the child. How about what's the difference between static and dynamic binding? Static binding happens at compile time. They're usually known as an overload. So we have several different functions with the same name, and the compiler will choose the correct one based on the utilization of the function at a compile time. The other form is a dynamic binding that will happen at runtime, and that's the dynamic overriding or the virtual function. So the correct method will be selected based on the object is creating dynamically. So let's review those two. So how we define overloading? Define two methods with the same name, in the same class, but with different signatures. So they have different sets of parameters, but the same name, same class. Functions can also be overloaded. So operators like the plus sign, for example, you can use for multiple applications. And this is a form of static bind that is resolved at compile time. We also talk about overriding. So we're redefining a method that has already been defined on the parent class. We're going to use the same signature, same set of parameters, and two different implementations. That's the dynamic binding, which is resolved at runtime. So let's do some exercise here to practice creation of classes. So we want to define a class called person that manages a student name and ID. So we're going to class some basic methods for accessing the name and the IDs, set initial value, get and set, things like that. The class will be a parent class, and we're going to include a virtual method display. So this is going to be a parent, as well as we're going to design it to be able to do virtual methods. So let's look at the creation of that. So you have the basic includes here, namespace, then class person, that's the name of the class. Then we're going to define the public side of the class, which will be the methods, constructor, destructor. So we make the destructor virtual because we're going to create virtual methods. Remember, every time we have a virtual method, we also need a virtual destructor. Then set initial values. There was two values to set, which is the name and the ID. Then we created a chain name, get name, that's a accessory. They see the word constant there. Then get ID, another accessory. Then our virtual method, which is display all. So it's going to display all the attributes of this class. And then on the private side, we have our attributes, the name and the ID. So notice here that a question similar to that on the test, it will require us to describe exact which methods we're going to implement here, or just give an example and create a few ones, but it will be much more clear if we ask something similar to this. So now let's derive that class. So we're going to define a class for the student that's derived from person. We're going to extend that to create two new attributes, number of class taken and GPA. And the programmer using this new class should be able to add a number of class. So as a mutator, we're going to be able to add additional numbers for the class that were taken and change the GPA, so be able to update the GPA. And also, we should be able to display all the attributes. So the display, new display that we're going to create it will allow us to display all the attributes. So we're going to include the person.age, which was the original person class that was created. So here class is student colon, then we define the type of access, we made a public person. So we derive from person. So here we have constructor, destructor, virtual destructor, because we have a virtual method here. Then set initial value. Now we have all the four attributes. We have capability to add class that was requested, and then change the GPA also requested. I also included here get classes and get GPA. Then of course we need our virtual display all, which are now going to display all the four attributes. And then on the private side, we have our two new attributes, total class and GPA. So here's a question, why not making that set initial value virtual? The reason for that is that set initial value from the parent has only two parameters. Set initial value of the child has four parameters, so we can make those virtual because in order to redefine, you need exact the same signature, meaning exact same number of parameters. So now we're going to implement the constructor and add class methods for the student. So student, colon, student, that's our constructor. We're just going to initialize the two new attributes. Then add classes. We're going to take that parameter number of new classes and we're going to add it to the total class that's already there. So it's a very simple method here. Now what we wanted to do is we needed to be able to write ways to use that class. So we want to declare an instance or an object of a student that is going to call Mary, and then we will be able to call the method add class to add 5 class to Mary. So student, which is the name of the class, Mary is the name that we want for the object, and then as simple, since there's a static object, we use the dot operator, so Mary dot add class 5. So now we're going to implement the display all in the person class. So display all in the person class has to display 2 attributes, right? The name and the ID. So void person, colon, display all, and constant because it's a accessor method. So left, we're going to display the name. The right, we're going to display the ID. Now we're going to implement the display all in the student class. You'll notice that the attributes on the student, or the attributes on the person class were made private. So the only way that the student has access to the attributes is through the methods on the parent, which is the person class. So here's what we decide to do here. So student colon display all. So we're going to use the method on the parent display all, which we just described here on the top of the slide. So person colon display all, that tells the compiler there we're accessing display all from the parent person. And now we display the remaining attributes, which is total number of classes and the GPA. So notice that we could also use the parent method to get the name and the ID, and then display internally. So those are your options. So you can use the methods because the parent attributes are private. You can access them through the methods, and then the 2 methods we could use. One was the original display all, and then display the remaining here, or we could get the name and ID, and then display here, and then display the remaining. So we want to do a quick exercise here. Declare an instance of object of the student we'll call Joe, and then we will do set initial values and display, which is, since it's a static, we use the dot operator. So here's what we get, student Joe. So we use the default constructor, then set initial values, say Joe dot set initial value, and then we set all the 4 attributes, the name, the ID, the number of classes, and the GPA. Then we're going to say Joe display all, which will display all those attributes, and it's just the one we described there. Then of course, so now we want to implement the method set initial values in the person class. So person is a parent. We're just going to get those 2 parameters and initialize and use that to set the person name and the person ID. Notice that I use another method on the parent to set the name. So chain name, and then I use that. Or I could access the attribute direct, which was name. So those are the 2 options that I have. I can use an existing method on the parent, or I can access the attribute direct, because the method is part of the class itself, is a person method within the class person, so he can access all the private attributes. Now what I wanted to do is set initial value for the student class. So notice that the attributes of the person, which is a parent class, were private. So the student can only access through the methods. So what we did is we took the person set initial value, so we use that, and then the other 2 we access them through the class. So either again, total classes is equal to class taken, so I did initialize the attribute direct, or I can use another method on the parent to change GPA to update the GPA. So those are the options we discussed already. So let's change a little the subject here, and we want to create a dynamic instance, an object, a dynamic object to the student, use a parent pointer. So you remember that once we do that, we have access to the dynamic virtual function. So we're assuming that constructor the student has allows us to initialize all the attributes of the person and the student, and we're going to invoke the constructor when create the instance. So let's assume that we have a new constructor, which is a known default that allows us to initialize all the attributes, and then we're going to call the display method. So here would be the function. So we create a pointer for the parent, which is a person pointer, which we would use to create a new student. So new student equal to student. So we're creating a student using a parent pointer. And then we have an access to a constructor there that allows us to initialize all the parameters, a known default constructor. Then we just call the method. When we do that, we access the display all. So here quickly, which display method was executed in the previous program from the person class or for the student class. As we look it up, we see that because we're using a person, a pointer, and creating a student, that allows us to do the virtual function replacement. So in that case, the student class method would be used because that's the dynamic replacement. That's the virtual function or the polymorphisms associated with the virtual function.